Okay, guys, we will solve some question about chapter 25. So this is my first question, and in the question it says there are two spherical and they are connected by wire. This is my wire, okay. And also there is a keyword here: the charge on sphere in equilibrium. What does it mean? The charge will not be transferred by each other. Okay, so the Q1 and Q2 will remain same. Okay, let's continue. Find the ratio of magnitude of the electric field at the surface of sphere. So how can we calculate electric field for sphere? It is easy. I know K Q over R square. I will use this part. I will not write key A, just I will use the key with short way. Anyway, let's continue. There is an important thing here. There is a hint. What is it? If they connect each other, their potential are same. Even you can imagine if we have some parallel connection with this way, we can say their potential are same. Potential difference are same. So it is similar. Just assume with this way. As we know, their potential are same. Just say this is V1 and this is V2 and their potential are same and we can call V. Okay, continue. I can write V1 here, V2 is here, perfect. When we make some ratio, we can cancel this part, and also we can write Q1 over Q2, Q, R1 over R2, isn't it? Yes, you can write this way. And now we can make some ratio for A1 and A2. I can write A1, this is A1, and this one is A2. I want to make the ratio, so just I will put all the information here. We can cancel K, you can see, we can cancel this part, we can write Q1 over Q2, and if I am not wrong, R1 R square over over R2 square. Okay, when we use that information, finally your result return this part. Okay, I hope you don't make any problem with this one. We can continue with the other question. Okay, look at this question. A uniform electric field of magnitude, this voltage, and in negative direction, y in negative y direction in figure, the coordinate system is this part, and they give coordinate system. Calculate the potential difference VB and minus VA. Okay, how can I write the potential difference? I know potential difference equal minus electrical field dot ds. Okay, can I write this way? Yes, you can write this way, but be careful. My electrical field is going to that part. Okay, so my displacement starting from A to B. Okay, maybe we can say it start from A to C. Say this is C point. Okay, it start from A to C and then C to B. So how can we write its limitation, integral limitation? It start from A to C. Can you see? This is say this is my first path, and this one is second path. And for first part, I will write this one, this integral, and this one is for second path. Okay, and we can put the limitation. What about the limitation of this second path? It starts from C to B. Can you see? Okay, we write all the information. What is the dot product? If there is dot product, you need to multiply with cos theta, isn't it? So now we can write this information. E is constant, E is same, E is uniform. Uniform means it is constant. So you can take the E, the outside of here, okay? And cos, what's the cos theta? Look at this one. My pet, say ds, is starting from A to C. So ds is going to here and electrical field is going to opposite way. And the angle between ds, say ds1, this one is ds2, okay? The angle between ds1 and electrical fields just 180, okay? And now we can put the coordinate system. It is writing here. This is x1, x coordinate system. This belongs to x coordinate system. This one is y coordinate system. Again, this one is, say this is x1, y1, and x2, y2. Okay, so what's the from A to C? Can you see this is y coordinate system, isn't it? So can I say what's the y if I write this part? Maybe even I can write it with this way. What's the A? A is, this one is, so this one is x, 0.3 minus 0.3. This one is, maybe I can write here, minus 0.2. So what's the B? I will write here. Maybe I can show with the different color. Give me a second, I will change my color. Okay, so here, what's the x? X is 0.4 and y is 0.5. Maybe I can write here. This is 0.5, okay? Maybe, I don't know. I can write here, 0.5. So what is the C? It starts from A, which is minus minus 5. Give me seconds. There is a some. I think, did I make mistake? I will check it. Oh, sorry. This one is 0.3. It's my mistake. Sorry. This one is 0.3. This one is 0.2. Okay. Yes. So it starts from minus 0.3 to C. What's the C? 0.5. Just so you can see, depends on the y coordinate system. So I will take y coordinate system. Okay. So it starts from minus 0.3, which is this one. Okay. And it's finally it stops here to at C point, which is 0.5. This is my limitation. Okay, perfect. And then again, look at the cos 90. Maybe we can erase to show better, with better way. Give me a second. Okay. Sorry, I will remove this part. Okay, perfect. So, firstly, we can check the cos theta. What's the angle? Look at this part. This is my ds2, isn't it? Yes. And maybe I can show from here. ds2 is going to on positive x-axis, and electrical field is going to minus y-axis. Okay. So the angle between electrical field and my way is 90 degrees. So we write this part. Okay, I will define its limitation. What's the limitation? It starts from here. Can you see? It moves on x coordinate system. So just I will care x coordinate system. What's the x coordinate system? So it starts from minus 0.2. Finally, it stops at B point, which is 0.4. Can you see its limitation? Perfect. So, as I said before, it moves on x-coordinate system, so I will care this ds as a dx. I will take ds as a dx. For first part, we move on y coordinate system, so we take just the d8 coordinate system. So it means we will take integral depending on dy for first path, and for second path, of course, it moves from x coordinate system. So you take the integral depending on x coordinate. Okay, so cos 90 is 0. I know, it's nice. And finally, this gives -1. Now there is just electrical field here. Just we can write dy integral gives just y. Maybe I can show with this one. Give me a second. I will erase this part. Okay, I want to try delete it. Okay, so here, sorry, I will write this part. Positive electrical fields, and this dy gives just y information, and we need to put the -0.3 and 0.5. Just we will put that information. I can write here electrical field multiply. First I will put 0.45 minus 0.3, and it gives, this one is 0.8. And I know electrical field. What's the electrical field? This one. Just if you put that information, finally you can calculate the potential difference. Okay, nice. Let's move other question. Okay, look at this question. An insulating rod, yalıtkan şöyle bir çubuk, having linear charge density lambda and linear mass density, be careful, mass density, it's not charge density, is given. Okay, it starts from rest. This is my keyword. Be careful for this one. So it is quite important. And it gives electrical field. Electrical field is perpendicular to this part. Okay, nice. And determine the speed of the rod after it has traveled 2 meters. Okay, look at that part. So the electric field is going this way, and also this rod moves with this way. Say this is ds. So if you look at the angle, firstly, we draw the ds. It will be important for us. I will come back. But in the question, it is asking to determine the speed of the rod after it has traveled 2 meters. Just assume it comes to here. Okay, so it moves like 2 meters. Anyway, you can understand. You are clever, guys. So how can I calculate its speed? Of course, if I use energy transformation, I know total energy is conserved, always conserved in isolated system. So if I use that information, I can calculate easily, because there is a speed information in the kinetic energy, isn't it? Yes, you can calculate. So just maybe we can write from here, and then we can return our question. I know total energy is conserved. How can I write it? K initial plus potential initial, K final, U final. Okay, so if I write that information, maybe you can take this one to here. But firstly, kinetic energy at initial state is 0, isn't it? Because my speed is 0. In the question it says, is released from rest mean my first velocity is 0. And of course, kinetic energy at initial state is 0 as well. Perfect. And then if write kinetic energy, can I write at final state here mv square? Perfect. And this is speed, be careful, not potential. And minus delta v. Can I tell delta u? Can I write like this? I know delta u is, maybe I can show here, delta u is u final minus u initial. Just I take from that part. Okay, perfect. If I know delta u, can I calculate the speed? Yes. What is the potential energy difference? Potential energy difference equals to q multiply delta v. Potential difference, not potential energy difference, potential difference. Okay, if I calculate delta v, and if I know q, I can calculate these potential energy differences, and then you can calculate the speed. Firstly, I need to calculate delta v. How can I calculate delta v? Delta v equal minus electrical field multiply ds. So I can come here. What's the dot information? I know that information gives cos part. Dot product gives cos theta. What is the cos theta? I want to look at this one. Electrical field is going here and this is going here, so they are parallel each other. The angle is 0. So this part gives 1. Perfect. So, and what is the ds? ds is on x coordinated system, isn't it? Can I say this? Can I write this one? Can I use ds as a dx? Yes, you can use it. And then just when we put that information, finally, be careful. What's my, maybe I need some space. I can write here, give a second. I need to write here. Okay, perfect. Okay, so it will be dx. And my limitation, say this is my first point, say 0, and it moves to here, like 2 meters. Can I write my moving starting from 0 to 2? Yes, of course. And electrical field dx, this is constant, electrical field constant, dx give x. You can write this part, electrical field and 2. But in the solution, they said they use d instead of 2. Okay, we follow same thing. D is 2, no worries. Okay, D is here, which is 2. I will continue with, I will follow the solution anyway. So my potential is electrical field D. And what is the potential energy? Just you need to, this is delta V, you need to multiply by charge. What's the Q? It gives lambda information. Perfect. And now I have to use that information. Okay, Q is equal charge density, linear charge density, multiply L. Multiply L means this length, the length of rod. Okay, so I put that information here. I know finally we calculate this part. Okay, we can continue from here, and this part is lambda L E D is coming from delta U. And look at this one. I don't know mass information, this part, but in the question they said linear mass density. How can we write the mass density? Mass equal, normally, be careful if they said linear. So can I write, sorry, it's not this part. Sorry. Sorry, not this one. Mu equal m over L. Okay, so it says we will not use volume because it says linear mass. So I will use that part. Okay, so instead of mass, I can write mu L. Okay. When I put that information here, this is mass information. Finally, you can calculate the velocity. If you put that information here, please convert microcoulomb to coulomb. And then finally, your velocity is 0.4 meter over second. And change if the electric field is not perpendicular to root. If okay, what it happened? We will see. Give me a second. I need some space. Actually, I will not solve this B part. It's not important things. Just try to understand. Forget this part.